All right, let's take a look at the next section. Exponential form and the log form. Let us recall. Oops, hold on. I need to get a pen. Let us refresh our memory. Let's recall. If I have 3 plus 3 plus 3, well, maybe plus 3 again, plus 3, plus 3, and plus 3. Isn't it troublesome to keep saying something like this? How many 3 do we have here? We have 7 of them. Is there any better way to keep express something like this instead of keep saying 3 plus 3 plus 3 plus 3 da 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 like that? We can express this in 7 times 3. That is indeed the beginning of multiplication. We have 7 of these add up together. So indeed, the other way around, if we say 3 times 7, are we talking about the same thing? Nope, not exactly. 3 times 7, we are talking about 7 plus 7 plus 7. We have 3, 7 add up together. So multiplication is indeed the extension of addition. Now we know multiplication. How about if I have this 3 times 3 times 3 times 3 times 3 times 3 times 3. How many 3 do I have this time? I still have 7. But I have 7 3 times together. Don't you think it's troublesome to keep saying 3 times 3 times 3 times 3? I lost count. How can we express this? We would make it becomes 3 to the 7th power. And 7 is what we call the exponent. So that is the beginning of exponential form. And 3 is what we call the base. So the exponent is the extension of multiplication. Remember 3 to the 7, the exponent is telling you how many times you are going to times the base together. Don't have the base and the exponents times together. 3 to the 7 is not equal to 3 times 7. So now we are going to extend that a little bit more. Let's see if I have a to the x power equals to y. That means a times itself, x times, would be equals to y. And we are going to transform this into a log form. We have log y with the base a equals to x. Now this is how we read this. So important to know how to read. You know, some people don't know how to read. They never call that. This is how we read. Log y with the base a. And the a will becomes a subscript. So write a little bit smaller on the lower right corner of the log. So whenever we have the a to the x equals to y, we can turn it into log of the result with the same base. That would be equals to the exponent. Let's have a little bit practice. Now remember, a to the x is equals to y. Then we can transform it. Now notice that I'm using a double arrow. That means if and only if one implies the other and the other implies the first. Can we convert? Let me put it in a box, maybe. Right? Can we convert the following to log form? Number one, we have 2 cubed is equals to 8. So I'm going to turn that into the log form. It would be log of the result. What is the result? 8. With the base, what is the base? 2. So you have to write the 2 a little bit smaller, which is equals to 3, the exponent. Let's take a look at another one. I got 4 cubed is equal to 64. Can we transform this into the log form? It would becomes log 64 with the same base. What is the base? 4, which is equals to 3. How about 12 square, which is equals to 144? Can I convert it into log form? It would becomes log what? 144 with the base of 12 equals to what? 2. Okay. Now be sure the log 144 and the 2 and the equal, they are on the same line. They are in the same font size, right? It's not one bigger, one smaller. But the 12, that is the base. So it's a subscript. So write a little bit smaller. Just like when we have 12 squared equal to 144, 12 equals 144, they are on the same line and same font size. The 2 is the superscript, that is the exponent. Don't write it too big. Sometimes some students, they use the same size, font size, and make it very confusing. Let's see another one. How about 7 squared equals to 49? I can turn it into log 49 with the base of 7 equals 2. Okay. Now again, we're using the double arrow in between. So it's one line, one equation implies another. That is not an equal sign. Please make sure you don't put down the equal sign. If you put down the equal sign, that will be wrong. You are telling people 49 is equal to 2. That is not right. Number 5, I have 10 cubed equals to 1,000. Can we turn it into the log form? It will be log 1,000 with the base 10 equals 3. Number 6, x cubed equals to 15. We have a variable now. I don't even know what is x, but well, do we really care? We only need to convert that into the log form. So what would that becomes? Log 15 with the base of x equals 3. Okay. Now again, the question is important. Some students see x cubed is equal to 15. They will try to find out what is the x because they do not understand the question. Oh, sometimes we do that. I see that in my notes. Right? Number 7, e squared equals to x. So what would that be in log form? With the base e, good, equals to 2. We have log x with the base e equals 2. Let's try another one. 25 equals to 5 squared. So what would that be in log form? Now, good. Now, if you feel like you like to rewrite that, that would make you feel better. Rewrite it because the left-hand side equal to the right-hand side, then the right-hand side must equal to the left-hand side. Or if you practice enough, then maybe you can read the answer right away. But be careful. Don't jump too fast. We have the log 25 with the base 5 equals 2. Now, if you feel like that, maybe I should rewrite that, make it 5 squared equals to 25 first. Feel free to do so, right? No. Some students, they might need that. So think about, which way is better for you. Don't look at others. Oh, Johnny can jump, so I can jump too. And then turn out it becomes a problem. Let's see the other way around. Can we convert backward? Can we convert the following to exponential form? We have number 9, log 100 with the base 10 equals 2. Now getting a little bit harder because I wipe up the equation, the formula, right? But hopefully we can tell too. We have the base raised to the exponent is equal to the result. What is the base this time? 10, right? So 10 becomes much bigger now because it's the base. And raise it to the second, to the third. So 2 will be a little bit smaller because it's the exponent, which is equals to 100. Okay. How about another one, number 10? Log 81 with the base 3 is equals to 4. So now I want to turn it back into exponential form. Something, what is something? What is the base? 3. Raise it to the fourth equals 81. Okay. Now, some students, they just try to make sense out of it. Oh, I know 3 to the 4 is equal to 81, so I know how to put them in the proper place. But be careful. Sometimes you may not be able to do that. You really need to know how to convert them. How about log A with the base B is equals to X? Now, you see this one, you have no way to tell which one go where. I have the base raise it to the exponent. What is the base this time? B. Raise it to the exponent. What is the exponent? X, which is equals to A. Let's try another. How about log 10 with the base E equals to X? So what would that becomes? That would be, what is the base this time? E. Raise it to the X. That would give me 10. So far so good, right? All right, now it's the time for you to have some fun. Let's try out this. And let's try out this. So you have 10 points on the table. Oops. Well, how about we want to evaluate the following without using a calculator. Wow, so that becomes a little bit interesting. Let's see, I believe we are on 13, is that right? We have 12 before? Well, yes, we have 12. Okay, so 13. You see, it's important to write down the index. Log 49 with the base 7 equals to what? Can we tell what is the log 49 with the base 7? Well, sometimes it's hard to think of, especially at the very beginning. We are indeed thinking of, hey, this is equal to maybe a question mark. Can I convert this back into the exponential form? We can make it becomes 7, raise it to the what is equals to 49. So now, can we identify what would be the question mark? 7 to the second is equals to 2. So the question mark indeed is equals to 2. So therefore, now make it clear. Don't just say question mark equal to 2. There is no question mark from the beginning. So we would say log 49 with the base 7 is equals to 2. Let's see another one. 14. If I have log 27 with the base 3, what would that equals to? I am thinking of, hey, this may be equal to a question mark, right? Or you could let it be x2. Let me convert it back into the exponential form. 3 to the what is equals to 27. This is what I am thinking of. So can we identify and tell me what is the question mark? Question mark would be 3. right? Because 3 cubed is 27. It's not 9, right? 3 to the 9 is not 27. Don't think of the base and the exponents times together. Let's answer the question. We have log 27 with the base 3, which is equals to 3. Let's see another. This time I have log 1 over 6 with the base 6 equals to what? Wow, that one is even hard to think of. So let's convert this into an exponential form first. I have 6 raise it to the something is equals to 1 over 6. Can you tell what is the question mark? It would be negative 1. Very good. 6 to the negative 1 is equals to 1 over 6. Now, sometimes, when we practice more, we can directly think about this in our head. But when things getting more complicated, don't hesitate. Hey, let's convert this into the exponential form first, and then see what would that becomes. So we got the log 1 over 6 with the base 6 is equals to negative 1. How about next one? We got log radical 6 with the base 6. What would that equals to? Wow, that's getting a little bit more complicated. So let it be x. And then let's convert it. So now I have 6 to the x power, which is equals to radical 6. On the left side, I have x to the something. On the other side, I have a radical form. Can I turn the radical form into an exponential form? That would be 6 to the what? 1 over 2. So if that is the case, can you tell what is x equals to? X is equals to 1 over 2. Right? The base are the same. The exponent must be the same. Now note that we are using the n root of a, which is equals to a raised to the 1 over n. Okay? So answer the question. Therefore, log radical 6 with the base 6 is equals to, what is that equals to? 1 over 2. Because I let it be x, and turn out later on, I find out that the x is equal to 1/2. 17. We got log 9 with the base 81, which is equals to x. That one is getting more interesting too. It's hard to think of 81 raised to the what would be 9. So let's do it step by step. Let's convert it first. I have 81 raised to the x power. That is equals to 9. Well, it would be hard to think of 81 to the first is already 81. What we could do is we could turn both sides to have the same base. 81 happens to be 9 squared. So now I have 9 squared to the x power is equal to 9. So that means 9 raised to the 2x is equals to 9. And now 2x is equal to 1. Because we have an exponential form, they are equals and share the same base. Their exponent must be the same. So x is equals to 1 over 2. So finally, let's answer the question. What would be the log 9 with the base 81? That is equals to, what's that equals to? 1 over 2. So far, so good. Let's see another one. How about we got the log x squared with the base x? Well, what would that equals to? Please stay focused, and then we can move faster instead of everyone waiting for you. You can think of what is the log x squared with the base x. Hard to think of. So we let it be something. Well, maybe this time I don't want to use x because we already have x. So we can use some other kind of variable, maybe m, or maybe a question mark. That is absolutely fine, right? Question mark is just a variable. So I turn it into the exponential form. So I have the base, which is x, raise it to the exponent, which is a question mark, equals to what? X squared. Very good. So now, hope that I can see that better. I have two exponential form. They are equals, and they share the same base. So that means the exponent must be the same. So what can we tell about the question mark? The question mark is equals to 2. So let's summarize that. So therefore, the log x squared with the base x is equals to 2. How about log 11 with the base 11? Can you think of something? Or do I have to make it becomes a question mark and do that? 11 raise it to what is equal to 11? 1. How about log a with the base a? What would that equals to? I'm thinking of the base a, raise it to what would be equals to a? 1. Now, so indeed, we have something special here. When we have a log a with the base a, that will always be 1. So when we log blah, blah, blah with the base blah, 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 we got 1. We don't even need to worry about what is the blah, blah, blah. How about log 1 with the base 6? Can we think of something? Hey, maybe I can see that right away. Okay, let's it be a question mark. Let's turn it back into the exponential form. I have 6 raise it to something which is equals to 1. Can we identify what is something? What would be the question mark? Would that be negative 6? 6 to the what is equals to 1? Not 1. 6 to the 1 is 6. 6 to the 0 is equals to 1. Okay. Remember, we have the a to the 0 power. That would be equals to 1 as long as the a is not equal to 0. Now you see, it's important to know some of the rules, right? So now everything is cumulative. So let's answer the question. So therefore, log 1 with the base 6, what would that be? Equals to 0. How about 22? What would that be? Let's see. This would be log 1 with the base a. Again, I'm thinking of, hey, a, raise it to the what? It would becomes 1. So what would be the answer? It would be 0. Now indeed, that gives us another formula. Log 1 with the base a, that would be equals to 0. Now, of course, the a cannot be 0. So far, so good, right? All right, now let's turn to the next page. Well, take a look at 2 special kind of log. We have the common log, that will be the base 10. When we have a common log, we don't even bother to write the base. It's kind of like we have an invisible base. So whenever you see the log 1000, right away, you know that, hey, this is a common log. The base will be 10. So can you tell what is that actually equals to? We have the log 1000 with the base of 10, right? Although when we practice more and more, we don't even bother to write the middle step. We know the base is 10. So in our mind, we are thinking of 10 to the what would be equal to 1000. So what would that be? That would be 3. Or if I have log 10 to the 8th power, wow, that is interesting. What would that be? That would be log 10 to the 8, raise it, with the base 10. So in my mind, I'm thinking of 10 to the what is equals to 10 to the 8. So can you tell me what is the what? It will be 8, right? Now maybe I'm going a little bit fast. This is just like the previous problem. We are thinking of 10, raise it to the question mark. That will be equal to 10 to the 8th power. So what is the question mark? It would be 8. How about log 10? Just simply log 10. What would that be? That would be 1 because the base is 10 now. So this would be simply 1. How about log 1? Can you tell what would that be? Is log 1 equals to 1? Not quite. What is log 1? Log 1 is equal to 0. Okay. Now that is a common log, and we do see that in our calculator. There is another type of log, very popular. Anybody knows? We have the natural log. We love natural. Nowadays, everything say natural this, natural that, and it costs more expense, costs more. What is the base? The base will be E. Anybody know what is E? E is a very special constant, just like pi. What is E equals to? Approximately, and you should remember that. I'm getting old, I'm losing my memory. So you should help me. This is 2.71828184591 approximately. Can you remember that? Yes, you can. Yeah. That's your boyfriend's phone number. 718-281-8284, extension 591. Isn't it? At least you should remember the area code so you know you are not having a long distance relationship. Now, why the E is so special? We will talk more in the future in pre-cal and calculus, and then you will see why so interesting about that particular special constant. But we do have another type of log with the base of E. We call this the natural log. And the way to write that is ln. We just write the ln, the natural log. Let's say the natural log of E to the 7. What would that means? That indeed is talking about the log E to the 7 with the base E. Okay. Now at the beginning we write it out like that, but when we practice more, we don't even bother. We know it's a log with the base E. Can we identify what would that equals to? If I have log E to the 7 with the base E, that would be 7. Very good. This would be just like the second one from the other side. We are thinking of E raise it to the question mark, which is equal to E to the 7. So, of course, the question mark would be 7. How about the natural log of E? What would that equals to? That would be 1, because now the base is E. And what would be the natural log of 1? That would be 0. So far so good, right? It's really not that bad. Everybody got that? Okay, let's take a look at this. We have 6 pawns on the table.